All right, second page of the review. Number 10, write the definite integral for the area of the region lying in the upper half of this ellipse, given by 4x squared plus y squared equals 4. Okay, it wants me to write an integral to find the area above the upper half of an ellipse. So basically, I have an ellipse, and it wants me to find the area up here. It wants me to find the area above the x-axis. So I need to know a couple of things. First of all, I need to know, well, where am I going to start and where am I going to end? And then I need to make sure that I use this line, right? I'm looking for the area up to whatever that line is. I don't want to use the bottom half. I don't want to use the bottom half of the ellipse. I want to find the area of the top half. So first thing I need to do is, well, first of all, I need to figure out what this equation even looks like. So let's take our 4x squared plus y squared equals 4, and let's turn that into a y function, right? Let's get y by itself. So I'm going to minus 4x squared from both sides. So I get y squared equals 4 minus 4x squared. And then I'm going to take the square root of both sides. So I get y equals the positive and negative root of 4 minus 4x squared. So now you have to make a decision. Which one of those, the positive or the negative, represents the line that you're interested in? And hopefully it's obvious. We are interested in the positive version of the square root. The negative version is going to give me this line down here. We don't want the negative. We want the positive. So my function that I'm using is y equals square root 4 minus 4x squared. So that's my function. But now I need to know, where do I start, where do I end? Because I know that I'm going to take the integral of the square root of 4 minus 4x squared. But I need to know my bounds. Where do I start, where do I end when I take this integral? Well, I know that I start and end where I cross the x-axis. So I know that y is going to equal 0. So I'm going to take my function, my square root 4 minus 4x squared, and I need to set that equal to 0. So that means that 4 minus 4x squared equals 0. So that means that, 4 times 1 minus x squared equals 0. So 1 minus x squared equals 0. So 1 equals x squared. So x is going to equal positive 1 and negative 1. So that's where I am crossing. I am crossing at negative 1 and positive 1. So my bounds, where I'm going to start and end, is I'm going to go from negative 1 to positive 1. And that will give me the area of the upper half of the ellipse. Okay, number 11. If the integral from negative 2 to 5 is 7 and 2 to 5 is pi plus 1, it wants me to find these three different definite integrals. Okay, so I want to focus on the fact that from negative 2 to 5 is 7, and from 2 to 5 is pi plus 1. So when I look at what just happened, this is old stuff. We don't want that anymore. Go away. Thank you. When I go from 2 to 2, when I'm going, this part A right here, when I'm going from 2 to 2, we've talked about this. It's come up in the notes. My integral is 0 because I'm not moving. I'm not integrating the area of any length. I'm going from 2 to itself, which is 2. When I'm going from 5 to 2, part B, well, I know that when I go from 2 to 5, it's pi plus 1. But I'm not going from 2 to 5. I'm going from 5 to 2. So I have to take the negative of that. Remember, that's the negative version of going from 2 to 5. So I would get negative pi minus 1. When I'm going from negative 2 to 2, I don't know what negative 2 to 2 is, but I know that negative 2 to 5 is 7, and I know that from 2 to 5 is pi plus 1. So if I minus those, so basically I've got two areas, right? Or two, I'm going to draw it like it's a line. If I go from negative 2 all the way to 5, I've got 7. But going from positive 2 to 5, this little piece right here is pi plus 1. So I want to take 7 and I want to minus pi plus 1, which just becomes 7 minus pi minus 1. So 6 minus pi would be my area for part C. Okay, number 12. Use the fundamental theorem of calculus to evaluate going from the integral from negative 1 to 1 of the cube root t minus 2 dt. So I'm going to rewrite this, negative 1 to 1 of t raised to the 1/3 minus 2 dt. So the fundamental theorem of calculus tells me to take the integral. All right, so t to the 1/3, I've got to add 1, so that becomes t to the 4/3. But I have to multiply by the reciprocal, 3/4. And then my minus 2 becomes minus 2t. And I would normally put a plus c, but this is a definite integral. So my c is just going to end up canceling away because now that I have the integral, I just have to evaluate that going from negative 1 to 1. So all I have to do is, first of all, plug in the 1. So 3/4, 1 raised to the 4/3, minus 2 times 1. And then I have to minus plugging in negative 1. So 3/4, negative 1 raised to the 4/3, minus 2 times negative 1. So when I clean this up, 3/4 times 1 to the 4/3. Well, 1 to the anything is just 1. So that becomes 3/4. 2 is still 2. So I've got 3/4 minus 2. 3/4 times negative 1 to the 4/3. Well, negative 1 to the 4th is going to give me a positive. And then I'm going to take the cube root of it, which is going to still give me a positive 1. So this becomes minus 3/4. And then negative 2 times negative 1 is positive 2, but I'm minusing that. So then I get minus 2 again. So my 3/4 cancel, and I end up with negative 4. So that would be my integral from negative 1 to 1. My value is negative 4. Okay, number 13. Consider big f of x is the integral from x to 1 of this function. Find f prime. Okay, so this one we're using our second fundamental theorem of calculus, which tells me, because it wants me to find f prime of x. So that means that I have to take the derivative of an integral, right? I'm taking the derivative of this integral. And the second fundamental theorem of calculus tells me, okay, take the top number and plug it in. So f prime of x is going to equal the square root of 1 plus 1 squared. And then I have to multiply that by the derivative of the top, which is 0. Then I'm going to subtract. Let me get rid of this. I'm going to subtract. I plug in the bottom. So square root of 1, not x yet, the square root of 1 plus x squared. But then I have to multiply by the derivative of the bottom, which the derivative of x is 1. Well, that's nice because this part just cancels out. So f prime of x is equal to negative root 1 plus x squared. Because when I times that by 1, I just get negative root 1 plus x squared. Now it wants me to plug in a 5. So f prime of 5 equals negative root 1 plus 5 squared, which equals negative root 1 plus 25. So I get negative root 26. So I'm going to stop right there. If this was the free response section, you could have stopped, whoops, don't erase. The free response section, you could have stopped right there. All you'd have had to do was plug in the 5 and you wouldn't have had to simplify. But on a multiple choice, you're going to need to be able to make them match. Okay, number 14. Let f of x equal x squared minus x, or the integral from negative 2 to x squared minus x of e 2 to the t squared dt. At what value of x is f of x a minimum? Okay, anytime I see minimum, I think of critical values, right? I need to get f prime of x to equal 0 so that I can find my critical values. And then I need to check and make sure that at those values, I end up with a maximum or a minimum. So we would make that little table. I would put my critical value right here, and I would check something smaller, something bigger, and if this is negative and this is positive, that means my function is going down and then back up, which makes that a minimum. So that's what I'm looking to do. I need to take the derivative, set it equal to 0, find when that happens, and then check the left and the right. So let's take the derivative of this wonderful mess right here. So f prime of x equals, to take the derivative of an integral, I plug in the top. So e to the 2, and instead of a t, I'm going to put x squared minus x squared. So I plugged in the top, and now I have to multiply by the derivative of the top, which is 2x minus 1. Now I plug in the bottom, but the bottom is just a constant. So I'm not going to go through the work of plugging in the bottom because I know I'm just going to end up with minus 0 because I'm going to multiply by the derivative of the bottom, which is 0. So it's all going to go away. So really, this is all I'm worried about right here. Now I need to set that equal to 0. So I need e to the 2 times x squared minus x squared, wow, times 2x minus 1. I want that to equal 0. Okay, e to any power. It doesn't matter what I plug in. E raised to any power, I cannot make it equal 0. Okay, I can't plug any exponent. I can't make any exponent that will turn e into a 0. So this is never going to be 0. So all I have to worry about is what makes this one equal 0. So 2x plus 1 2x equals, 2x equals 1. So x equals 1/2. So I know that at 1/2, I have a critical value. That means my slope is 0. What I don't know is my function doing this or this. I don't know which one. I know it's doing one of them. So let's pick a number less than 1/2. Let's pick 0. And let's pick a number bigger than 1/2. Let's pick 1. And we are looking to see what my slope is doing. I want to know if my slope is going positive and then negative, or negative and then positive, right? Because right here my slope is positive, then it goes negative, so that means it's a max. Right here my slope is negative, it changes to a positive, so that means this is a minimum. So when I plug 0 into my slope formula, okay, I am plugging into this one right here. When I plug a 0 into that, my e to the 0, I end up with f prime of 0 becomes e to the 0 times negative 1. Well, e to the 0, anything to the 0 is just 1. So that becomes negative 1. So this is a negative, and I guess I don't care about the 1. All I care about is that this gives me a negative. So that means my function is going down. Now let's double check to see if after 1/2 it starts going back up. So if I plug in a 1 to this function, e to the 2, let's see, f prime of 1. E to the 2 times 1 minus 1 is going to become 0. So that whole top is going to become 0. So this whole thing is just going to become 1. Times 2 times 1 minus 1. Well, 2 times 1 is 2, minus 1 is 1. 1 times 1 is 1. That's a positive number. So I have a minimum. I have a minimum at 1/2. So I would say that f of x has a minimum at x equals 1/2. And there was my work to show that that's true. Okay, let's move on. Number 16. Find the average value of f of x equals 3x squared minus 2 on the interval 0 to 5. So remember, average value, I have to take 1 over b minus a, and then I take the integral from a to b of whatever my function is. So I have my function f of x. So let's take the integral. We're going to go from 0 to 5 of 3x squared minus 2 dx. And once I find that answer, I'm going to multiply that by what? 1 over 5 minus 0 is just 5. So it's just 1/5. So the integral of 3x squared, that becomes x cubed. And then I times by 1/3, which makes the 3 go away, minus 2x. And I don't have to worry about a c value because I'm evaluating this from 0 to 5. So right now, I'm just doing this part. I still have this 1/5 out in front that I'm not multiplying by quite yet. So 1/5 is going to get multiplied by, let's plug in the 5. So 5 cubed minus 2 times 5 is 10. And then I have to subtract when I plug in a 0. Well, 0 cubed is 0 minus 2 times 0. Well, that just gives me 0. That's nice. So 1/5 multiplied by 5 cubed is 125 minus 10. So I get 1/5 of 115, which is going to equal, not 1/5, 1/5 of 115. So that's going to equal 1/5 of 100 is 20. 1/5 of 15 is 3. So that's going to equal 23. That would be my average value. So going from 0 to 5, on average, my value is 23. All right, number 17. Evaluate the integral. X times x squared minus 1 to the 4th dx. Okay, you are welcome to multiply x squared minus 1 by itself 4 times and then multiply an x and distribute it through everything. Or we can just use u substitution. So let's let u equal, we're going to start by trying the inside, the innermost function. So u equals x squared minus 1. So that means that du equals 2x dx. All right, so I have my dx. I have my u. I just need an x to go with it. So I'm only going to move the 2 to the other side. So I want 1/2 du to equal x dx because I want to replace the x and the dx when I plug it in. So I'm going to take the integral of u to the 4th du, and I have to put that 1/2 right here is going to go to the front. So 1/2 integral u to the 4th du. Well, that's not too bad. 1/2 times u to the 4th becomes u to the 5th. So I need to multiply by 1/5 to counteract that I'm going u to the 5th. And I've got a plus c to worry about. So 1/2 and the 1/5 just becomes 1/10 u to the 5th plus c. Now, because we're not evaluating this from one endpoint to another, I need to plug in my u. I need to put the x squared minus 1 back in. So my answer is going to be 1/10 of x squared minus 1 to the 5th plus c. I can't just leave it a u because I never was able to change my bounds because I don't have any bounds. It's hard to change something you don't have. All right, number 18. Evaluate the integral of sine x over 2 dx. So let's start by sine x over 2. This really is the integral of sine, and I could rewrite that as 1/2 x, right, dx. So let's let u equal 1/2 x. I don't want the dx. 1/2 x. So that means that du is going to equal 1/2 dx. Now, I don't want the 1/2. I just want the dx part. So I need to move the 1/2 to the other side. So 2 du equals dx. So let's plug everything in. So the integral of the sine of u, du, but I've got that 2 that came in with the du, so that can just go out in front. So that equals 2 times the integral of sine is negative cosine of u, and then I have a plus c, so that becomes negative 2 cosine u plus c, and when I plug u back in, negative 2 cosine of x over 2, or 1/2 x, plus c. Okay, number 19. Evaluate the integral of cosine cubed, or I guess cosine of 5. That bugs me so bad trying to read that. So I'm going to rewrite that right now. The integral of the cosine of 5x cubed times sine of 5x dx. Okay. Normally, we tell you to try to plug in the innermost function, like that 5x, as my u. But if I let u equal 5x, then du equals 5 dx. And that really doesn't help me eliminate anything. So let's go one step out. Instead of 5x, let's let u equal the cosine of 5x. And then du is going to equal negative sine of 5x, but then I have to multiply by the derivative of the inside 5, and then I get dx. So before I move anything, du equals negative 5 sine of 5x dx. Well, I like the sine of 5x because that shows up right there. I just need to get rid of this negative 5. So negative 1/5 du equals the sine of 5x dx. And now let's plug everything in. The integral of u cubed du, but I have that negative 1/5 that had to come with the du, so I'm just going to put that out in front. So negative 1/5 u cubed du. Well, that's nice because now I'm not even dealing with trig functions at all. The integral of this just becomes 1/4 u to the 4th plus c. And I've got that negative 1/5 out in front, don't I? So don't forget about that negative 1/5. So I end up with negative 1/20 u to the 4th plus c. And I can't stop there. I didn't change my limits because I don't have any limits. So I need to plug u back in. So negative 1/20, and u was the cosine of 5x. But that's going to be raised to the 4th plus c.